Today we will learn how to do linear regression with the help of our calculators. So you will need your calculator. Almost all of you have an Inspire. A couple of you have different kinds, but you need to have that ready to go. You also need to have several handouts in front of you. One of them that you will need is the one that has these boxes on it and starts off linear regression problems will include 4 basic steps. This was not part of the packet that you could pick up at school, but it has been posted on the assignment for you to print out. In addition, you need to have the notes page that has the cricket on it. If you picked it up at school, we're going to use the front of that page. Tomorrow you will use the back. If you are printing it, only the front is included with today's assignment. The back is included with tomorrow's assignment for you to print out and complete. You also need the calculator instructions for your calculator, either these instructions for the Inspire or these instructions for the 8384. So I know that's a lot of papers to have out, but those are the things that we will be using today. We are going to talk about correlation, which is if we have some data and we were to plot those, does there seem to be a pattern to them? And we're mainly looking at, as we go farther out to the right, do the dots seem to be going up, or do they seem to be trending down, or do they seem to be all over the place? The language that we will use, if they seem to be trending up, like you see in this picture, we are going to say that it has a positive correlation. So what that would mean is that if we decided that we wanted to draw a line as close as we could possibly get it to those dots, maybe it would look something like this. The closest possible would mean if we actually measured the distance from each dot to the line, and then we added up all of those distances, what's the smallest that we could get? I'm just kind of eyeballing these, and I may be close or I may be kind of far off. The calculator is going to actually get the one where the total of all of those distances would be as small as possible. So I might just kind of guess that my lines would look like this. These lines both have a positive slope, which is the way that we know it is a positive correlation. The one on the left, the lines all seem to be the line and the dots all seem to be pretty close together, so we would say that that is a strong positive linear, because we drew a line, correlation or relationship. Those are basically synonyms. However, this one over here on the right isn't as close, but it's pretty good. So I would probably say that it is a moderate positive linear relationship or correlation, whichever word you like. Today we are also going to talk about something, and the calculator is actually going to give us a number for it. And the other thing that we are going to talk about is an R value. That will be our correlation coefficient. Or R value. The calculator will tell us R equals something. These R values will always be between positive and negative 1. If they are exactly 1, it is a perfect fit. every point is on the line. If it is -1, same thing. I'll talk on the next slide about the difference between R being positive and R being negative. If it is 0, there is no relationship at all. And what this sentence that I have typed out here, the closer it is to either positive or -1, the stronger the correlation is. So I'd say I've got a strong correlation if my R's are in here. If my R's are here, I'd say weak. And if my R's are somewhere in the middle, I'd say it's a moderate relationship. And we'll get a little bit more specific with that on the next slide. But R is going to be a number we get from the calculator. If it's positive or -1, it's a perfect fit. Every dot is on the line. If it's close to 1 or -1, the dots are pretty close to the line, like in my first picture up at the top. And if they're kind of in between, then it's a moderate one. But if the R's are close to 0 or actually equal to 0, we don't have much of a connection at all with these. Now the difference between R being +1 and -1 is the difference in whether we have a positive or a negative correlation. You notice if you look at these, that it looks like my line would be going down. This one looks like pretty much a perfect fit. This one, not so much, so I'm not sure what it is. In this case, R would be -1. If I have a negative correlation, R is going to be a negative number from the calculator. Back to my first slide, if I have a positive correlation, the slope is positive and the R is positive. They go together. So with the negative ones, R is negative and the slope is also negative. This one, R would be negative, but not as close to -1. No correlation would mean they're all over the place. I'm not sure. Should I draw a line that goes down? Or should I draw a line that goes up? Those all look about it. I can't even tell whether it needs to slope up or down. So that's no correlation or pretty close to 0 for the R value. All right, next what I want you to do is to take that notes page that has the cricket on it. And these are the same questions that you see on that paper and the same numbers. And we are going to talk through how we actually enter those on the calculator. So I want you to have those directions in your hand, either the directions for the Inspire or the directions for the Texas Instrument 8384, if that is what you are actually using today. And we are going to talk through these steps together as well. So I am going to model it with the Inspire. You need to have that notes page in front of you so you can continue to see these numbers. What I am going to have us do is to go to the calculator and we'll create a table, and we're going to first enter this left column of numbers for the temperatures. Then we'll go back and we will enter the ones for the chirps per second. So let me get my calculator up here so that I can do that. So looking at the directions for the Inspire, since that's what I can model, it says first go to the home screen. I'm in the scratch pad, so I need to push the button at the top right that has the house on it. And then I need to push 1, for either new or new document, depending on which version your calculator has right now. And then we want to add lists and spreadsheets, so that's choice number 4. You can use the cursor and scroll down till it's highlighted and then hit enter, or you may just push the button 4 for choice number 4. Because I've got a brand new document, I don't have anything already in there, but if I did this and, oh, I've already got a table in there, I need to clear some of those things out, I could use my up arrow and go up, not like that. I could go up until I have, not wanting to cooperate, until I have that box highlighted that has an equal sign in it, and it's under the A, and then I could do those steps in step number 3. I could press menu, and then data, and then clear data to get rid of it. I'm not going to do that since I don't have any numbers up here that I need to get rid of. You don't want to delete rows and columns. It's hard to get it reset back where you want to use these directions if you need to get rid of numbers. Then I can go to step number 4, and I need to go to that top box, so I can click up one more arrow so that my A is highlighted. I'm not sure why my version wants to highlight everything. And then I'm going to type in the name of that data, and that column was temperature, so I'm going to use my letters and type T, not there. If I have just that box highlighted, I will type T, and I'm going to do EMP for temperature. I find it a little more helpful if I don't use just a single letter. If I write a little bit more, it's easier for me to keep straight what it is. Then I am going to skip the equal box and go down to box number 1, and I'm going to start entering those numbers that I have on my Cricut page. So I am going to go through, and I am going to do 88.6, enter. Then I'm going to do 71.6, enter. 93.3, enter. 84.3, and enter. 80.6, and enter. 75.2, enter. 69.7, enter. 82 or 82.0, and enter. 69.4, enter. 83.3, enter. 78.6, enter. 82.6, enter. 80.6, enter. 83.5, enter. And 76.3. Be sure you remember to put enter when you get to the bottom, or the calculator will have trouble reading and understanding what you meant for it to say. I think it is always a good idea to do a quick proofread because it's easy to have made a typographical error in there. So I'm going to scroll back up and make sure that I don't see any mistakes that I entered in my numbers. And let's see if I'm almost there. And I think those look good. Then I am going to repeat the process. It says for me to go back up and go to the box B, and I'm going to label that. That was chirps per second. So you could type out chirps, C-H-I-R-P-S, so I think I'll just do C-H for that. And then we're going to enter those numbers exactly like we did before. So we go through our list and we get all of these numbers entered. .7, 17.1, 15.4, 16.2, 15, 17.2, 16, 17, 14.1. When you get down to the bottom, again, make sure you remember to hit enter. If you don't, if it's still over there on the left of the box like you see on mine, the calculator is going to think you had more X's than you had Y's. And it's going to give you an error message, and you'll need to come back and you'll probably see this, oops, I forgot to hit enter, and then you can go back and then things will work. Make sure that your two columns have the same number of entries in them, that you don't have one column that's longer than the other, or else you probably missed something as you were going through entering your data. And again, I'm going to do a quick double check of all of my numbers. And those look like they are good to me. So now we have completed those steps down through step number 6. Now, one of the things that we are going to be asked to do on that Cricut page is going to be to have a scatter plot. So we're going to have to figure out how we're going to draw the scatter plot. And we need to come up with the equation for that line. Or I tried to just guess where they went. We want the calculator to give us the exact line that should go between all the points. And then we're going to put that line in on the scatter plot. So those are kind of steps 2 and 3, or 1, 2, and 3 of the things that we're being asked to do. So in that left-hand column, the next things are going to be what we do to get the equation, and then we'll actually go ahead with graphing it. So we don't really want to get the equation right here. We're going to do a new page in this document that we created. To do a new page, you go up to that touchpad where you can either push in the middle or the left, right, top or bottom of the touchpad. And we look at those, and they don't quite have what we want. They have some things that will let us go to the next page or to go back a page. So we hunt around on the calculator keypad just a little bit. And if we go back to the buttons on the very right up at the top one is home, and up above it, it says off. The next one is doc, and up above it, it says plus page, which means add a page, add a new page. That's what we want. Since it's up above, we have to use the control button over here on the left, control, and then we push that dot button so that it really does plus a page. Our directions on our list say that we want to add a calculator page, so that's choice 1, so we hit the button 1, and now we have a calculator page. Looks like what we have when we're in the scratch pad. We're going to follow these steps, press menu, then we want to select 6 for statistics, so I push my number 6 on my keypad. Then I want to select 1, which is stat calculations. We are doing linear regression. We want to get a straight line to add on the graph, and we do y equals mx plus b, so we choose choice number 3, not y equals a plus bx. So we pick choice number 3. Now we need to tell it what the x's and the y's are. The x's, the x column was our temperature column, and our y's were our chirps column. So we use our drop-down menu, and we say the x's need to be temperature. Calculator is always going to give you these in alphabetical order, so you have to think about which one is the right one. The y's need to be the chirps per second. And then always notice what it says next. This one says the regression equation is going to be F1. We'll need that later. If you start with a new document every single time, it will always be F1. If you keep adding pages so that you do a bunch of problems all in the same document and you don't get rid of it in case you need to go back and talk about it in class or share it with a friend or double check it on the test later, you may have F1, F2, F3 different functions. So you need to know for this problem it's going to be F1. Then you click your tab button, however many times it takes to get down to OK, and then you want to OK that, so you can hit enter for that OK, and now it has a whole bunch of things that show up. So we need to think about what these are. First one just says, oh, he did a linear regression with mx plus b, so your regression equation is going to be y equals mx plus b, but then it tells you on that third line, m is really 0.21567874158, and then the calculator actually remembers even more places after that. And it tells you what b is. And then it gives some other strange things, r squared and r, and we'll talk about r in a little bit. It's going to be that correlation coefficient that I mentioned, but it's r, it's not r squared on that. So now we have all of this information in there. Now we can write that equation and the correlation coefficient down on our paper when we're ready to actually write the equation. I think it is question number 3 that asks you for the equation, but we'll get to that in a moment. Question number 1 asks us to draw the scatter plot. So let's go over to the right-hand side. That's top of the second column. We want to graph it. We want to draw that scatter plot. So we need a different kind of page. We need a page that'll do a graph. So we need another new page. So once again, it is Control Dot, so we have a new page. This time we want a data and statistics page, so that's choice 5, so I push the 5. And that looks kind of strange. It's got a bunch of dots, but they're just kind of randomly all over the place. Oh, it didn't tell me what the x's and the y's are. You see, it says click to add variable. So you're going to use that little touchpad up at the top to move your cursor so that it highlights down at the bottom, and the bottom needed to be the x's, and the x's for this problem were temp. Ignore those other strange things that all start with stat. We're looking for temp because that was our x's, and then we move our cursor over where it says click to add variable on the left-hand side, and those were the chirps per second. Now this starts to look like a scatter plot. So now, if we go back to our equation, our notes page with the cricket, it says to draw a scatter plot. So we've done that. And then it says to analyze the relationship. So this one right now, and we won't do this part on homework sets, this is just when we're trying to understand what's going on with it. When I look at that scatter plot, do I think it looks like it has a positive or a negative correlation? Do I think it looks like it's a really strong one, really close to an exact straight line, or not so close? To me, it looks like it's going up. It looks like I could draw a line with a positive slope going through there. That would be pretty close. It wouldn't be perfect, but it'd be pretty close. So if I do go back to my cricket worksheet, I've drawn my scatter plot, and now I'm looking, I say, when I look at it, I think there's sort of a positive linear correlation between, and then I'd always name my x's and y's, between the temperature and the number of chirps per second. So that's what I'd write in on number 2. We mentioned that number 3 said to write the equation. So we're going to write y equals our mx plus b. And this time we are going to look at what our calculator had. So, oops, I need to go back to that calculator page. Was that page 1.1 or page 1.2? I know it wasn't the graph here. So I'm going to go back a page so I can do this little symbol here to the right of that toggle means go back a page. So I'm going to click on I'm going to do Control and then click the left side of that. So yeah, that's the page I wanted. M was, and I'm going to round to 3 places, 0.216, x plus b, so plus negative 0.615 if I round back to 3 places. So that's what I write down on my part for number 3. Now, what I haven't done is, it would be nice to actually draw that line on my scatter plot. So I'm going to make the calculator draw this line for me. I'm going to go back to my calculator. I need to go back to my graph page. So that means I need to go forward a page. So now I want this blue part to the right of it. So I need to do Control and hit the right side of my toggle switch. So now I'm back on this. And now I'm looking back at my directions for the Inspire again. I'm on the right-hand side. I got down as far as step number 6. Step number 7 says press menu, then choose choice 4, which is analyze the graph. And then it says to click 6, which is regression. And then to choose 1, because I do mx plus b, not a plus bx, so click the 1. There's my line, and there's the equation written out again. Some of those numbers are a little bit hard to read because they go over the dots and the line. That's why I like to actually write it down from that calculator page, not from where I have with this graph on it. If we were doing this in class, you would be expected to show me your calculator screen with all of this on there and to have me initial that you had done it correctly. And sometimes on our test questions, we will also expect you to do that. Maybe we'll have you take a picture with your camera of what it looks like and send it to us, or maybe we'll be back in class and you'll be able to actually show that to me and have me initial it. But we do expect you to be able to do all of that with the help of your calculator. So now let's go back to our worksheet with the cricket on it of those things that we are trying to fill out. And we got steps 1, 2, and 3 done. And step 4 asks us to start analyzing what's going on. So this is where we're going to use that other piece of paper that I asked you to print off that looked something like this one right here. It said linear regression problems will include, and then it had a whole bunch of things. This is the model I'm going to be following and you want to be following as you do all of these problems on worksheets and homework sets. So I have these steps basically written out on the Smartboard presentation where it's a little bit easier for me to scroll through it one step at a time and talk about it and write on it as I want to. But it's basically the same thing. Your homework problems always need to have the line, so you're always writing in what is the y equals mx plus b, and these are from the calculator, and they are rounded to 3 places. You also always need to write down what is r. So we're going to look at that calculator screen when we go back to this step and write down r, rounding it to 3 places. But then we need to analyze, does that mean it's a good fit or a moderate fit or a weak correlation, a weak relationship? You are always going to write a sentence that fits this pattern exactly, no abbreviations on your variables. There is a, and you'll pick one, weak, moderate, or strong, depending on how close r is to 0 or 1 or in between. Is it positive or negative? Is r positive or negative? Is the slope positive or negative? Same thing. Positive slopes have positive r, negative slopes have negative r's. You must always include the word linear, because not in this class, but in future classes, you might be drawing a parabola if there's a u that fits those data points better than a straight line. So we have to say which one it is. I don't care if you use relationship or correlation, those are synonyms. You're going to write between, and then you're going to write out with no abbreviation. So in our case, temperature was the x's, and the y name is going to be the chirps per second. So to decide weak, moderate, or strong, we generally use kind of 0.85, 0.8, somewhere around there. If it's 0.85 or higher, 0.9, in terms of the absolute value, we'd say there's a strong relationship and our model's a good fit to the data. If r is around 0.8, 0.85, I tend to say it's a moderate relationship. Maybe 0.75 is also moderate. If it's close to 0, there's not much of a relationship at all. Exactly 0 is no relationship. We might say there's almost no relationship, or we might say there's a weak relationship. but that model is not a good fit to the data. So let's go back to our example now and see what we got for R. So going back to the calculator, this was on my calculator page. That was my 1.2 page if I look at my tabs up at the top. So I need to do Control back a page, left side of the toggle switch. And R is 0.83647, round to 3 places, that is just going to be 0.836. So that's what we're going to write down on that note sheet that we are doing. That R is actually 0.836, we write it down. You know, I think that's pretty close to 0.85. I think I'm going to choose to call that moderate. It is a judgment call. There's a moderate slope and R are positive, so I pick positive out of that pattern sentence that I gave you. Don't forget the word linear. I did correlation. You could do relation or relationship between temperature and chirps per second. No abbreviations written out in there. Question number 5 says to analyze the slope in the context of the problem. So let's go back to that page for analyzing things, which I have written out more or less right here. It went on and said that we're going to write out a sentence, and it's always going to be for everyone, and then you need to name the units. These square brackets means you need to fill in what the units really are. Grams, pounds, degrees, whatever they are. This word is always an increase when we are talking about the x's. For every 1 unit increase in the x's. Now for the y's, we're going to have to pick increase or decrease. And then we're going to say our model predicts an average. This is where we choose. Increase if it is a positive correlation, positive slope. Decrease if it is a negative slope. Negative correlation, the line going down. Then we're going to do of the slope, technically absolute value of the slope. Always positive right here. Even if the slope is negative, you drop the negative sign right here because the negative went into this word decrease. So then you're just putting the rest of what the slope actually is, units and y's. So keep that sample paper right beside you. As on the paper with the cricket, we are now going to write that part out. For every 1, and then we know our units, these were degrees Fahrenheit, and we always do increase right there in, and our x's were temperature, so we write that out. And then we write our model predicts an average, word for word, like you see on that sample. Now we have to pick increase or decrease. And we pick increase because the slope is positive and the R that we got was positive. And the slope was 0.216, so we write that down. And then our units in the Y variable are chirps per second. Chirps per second was basically the name of that Y variable in this case, but most of the time it'll be an increase of 0.26 grams in hydrogen or something like that. Every time you have a homework problem, you will write down the y equals mx plus b, rounding m and b to 3 places. R equals rounding to 3 places and include the plus or minus sign. And you will do those 2 sentences. There's some kind of a linear correlation between x and y. For every 1 unit increase in whatever the x is, our model predicts an average increase or decrease of so many, and then the units of the y variable. Sometimes the homework problems will ask you to use that model to make a prediction. So what we had was y equals sum mx plus b. That means, well, what happens if we plug 73 in, because temperature for this one was our x's? We don't want to use those rounded numbers for M and B, because once we round it, we can't reuse it and do any more calculating. So we want the calculator to use the M and the B that are not rounded, and to plug the 73 in there. This is what you have in the last part of the right-hand column of those directions. So let's go back to our calculator. We need to be on a calculator page. We can add a new one, or this is a calculator page. So my cursor's down there at the bottom, so I'm just going to go ahead and stay on this calculator page. I need to then, since I'm on a calculator page, that was step 3. Step 4 says to press VAR. That's the button right above the 9. Not Control VAR, like when we were storing things the other day, but just push the VAR button. Wow, it has a whole long list of steps. This is where I said back in the left column, step number 15, to notice what the calculator said for save regression equation 2. Ours was F1. So I scroll to F1. Remember, this is going to always be alphabetical. So scroll to the F1, hit your down arrow. If you go too far, go back up so that you're on F1. And your calculator prints F1 parentheses. This is like F of whatever. All we need to do is to type, what was it, 73 that we were trying to find? Type 73 so that it's inside those parentheses. It already had the parentheses there for us. We didn't have to type them. Just put a 73 in and hit enter. And then we're going to round that to 3 places, 15.129. And we are going to remember that. Go back to our Cricut note sheet and type in that the F1 of 73 gave us 15.129. And then we're going to label that chirps per second. And that concludes our lesson for today.